Hi, Jakub Kaluzny here and welcome to Instant Threat Modeling. This 5-minute video will give you enough material to copy my voice, and this is the topic for today: voice biometric authentication. Some say passwords are passé and why don't we use our voice for authentication? Here is how. So, the users enroll in the system by saying a specified phrase 3 times. I'm Jakub and my voice is my password. Now the rocket science AI-based machine learning solution knows who we are. The next time we log in, instead of using standard password, we say I am Jakub and my voice is my password. Et voila, we're in. Who are the threat actors? Okay, one is your twin brother or sister, just to prank you. The second one is somebody who can be in a close proximity, for example, at a cafe or work to record you. And the third one is just a random person on the internet. What on earth can go wrong here? Now, there are two models to deploy a voice biometric solution. The first one is just a dial-in number, and it offers less options to identify you first, so it relies solely on what you are, your voice, or additionally on what you know, such as an ID. The second model is a mobile application that has been previously paired with your account, so something that you have, and it implies the first attack vector. So without that thing that you have, a brute force is possible. How easy is to trick these systems for your twin siblings? False acceptance rate for the solutions I've tested in the last few years was somewhere between 1 and 5%. This means that 1 in 100 people has the same voice as you, at least for these solutions. The next attack vector is a replay. If the phrase to authenticate is the same all the time, I'm Jakub and my voice is my password, then the only thing you need is to record someone authenticating in a cafe and then replay it back to the system. So we've got a replay here. I remember one test when I needed to add some random noise in the background of the replayed recording for the system to let me in. If a replay doesn't work straight away, you can always try to find bugs in algorithms. I remember one. If the functions to verify the phrase correctness, words, and the voice authenticity itself are implemented independently, then you can try to mix the victim's voice, the victim's real voice, with the voice of the attacker saying the correct phrase. Voice or not voice, it is still an API, so technical vulnerabilities apply. One of those was changing the frequency of the uploaded WAV file in a way that it caused a denial of service when the system tried to unpack it. Deep voice adversarial AI is a great technique. With just a few minutes of someone's voice recording, you can generate a text, a selected text to be read by their voice. Machine learning systems are always probabilistic. One of the successful attacks I once triggered was to send a very noisy recording, and the system asked to repeat it on the very same call. I did it for the second time, and in the third attempt, the system lowered the false rejection rate enough to accept my fake voice. And the last one. Have you seen a 1992 movie, Sneakers? They've just recorded the victim saying random sentences. They cut the words in a way that they made the secret phrase and then played it back to the system. Instant mitigations always require two factors. A mobile app paired with the account is a second factor, client identifier is not. When buying voice biometric solutions, always ask about detailed false acceptance, false rejection rate data on different trust levels and cross-user authentication results. Detect replayed recordings. Don't get tricked by changed pitch, speed or noise. Detect noise and characteristics change during the whole recording. Make sure that your AI is better than the AI of your adversaries. For the web-based API, we've got the API-based threat model here. The highest error rate across your process is your error rate. Don't combine these values. And if your system can be tricked in a sneaker's way, well, maybe you should go back to passwords. This was instant threat modeling of non-deterministic software of future. I'm always happy to verify whether your solution is ready for your adversaries. Cheers!